before joining Nature, studying sex determination and notch signaling in vertebrate gut equilibrium. She is a true pioneer in the field of science publishing and communication, acting as the first ever female editor-in-chief of Nature. So thank you for being here with us, Dr. Skipper. We really appreciate it.
It's my pleasure.
Lovely. So yeah, I guess we should probably just start by, where are the questions? Yeah, so how you kind of started very much in academia, did a PhD and then some postdoctoral research. Kind of what made you switch to scientific publishing? Was it a long-term ambition?
It wasn't a long-term ambition, actually. Certainly the long-term ambition, and that kind of dates back to really actually my childhood, was a fascination with life sciences in particular, biology and research, discovery of new knowledge and so on. And that's why I went into research career to begin with. But it was actually interesting, as you never really know what something is like until you actually try doing it yourself. And so being a researcher at a bench ticked a lot of these boxes that I anticipated that, I'll be able, these ambitions that I'll be able to fulfill. But there were some frustrations. And for me, I think the main frustration was that, as you do your research, especially in the early stages of your career, you have to be very focused. You're focused on one topic, especially during your PhD. You have one subject that you're researching. And to do a good job, you really have to be focused on that. And as a postdoc, you can switch fields, but again, you have essentially one task at hand. And I'm quite eclectic. I have a lot of interests, and I was frustrated that while I was pursuing these other interests, even in research, trying to learn more about other fields and maybe try and address other questions, then I wasn't really true to pursuing the question that was sent to me either as a PhD student or a postdoc. So that frustration of having to narrow my focus too much led me to consider, could there be something else that I could do, very much still within the research community, focused on science, that could satisfy that desire of broader interest. And to be honest with you, I wish I had an exciting story how I became an editor. I actually fell into this. I literally saw an advert at the back of Nature for my first role, and it was associate editor on Nature Reviews Genetics. And genetics has always been my love, if you like, within biology and life sciences, that sort of understanding of inheritance and how the information that's encoded in our genomes is read out. And so I applied for the job, and in the process of doing the interview, I actually thought, my God, this is an amazing job. Why nobody had ever told me that this could be so exciting? And so I was very fortunate in being offered the job, and that was almost exactly 20 years ago, actually. So the rest is history. But that was the main driver. I definitely did not want to leave research in this broadest sense. So I don't consider myself a scientist now. I don't do original research, but I consider myself part of the research community or research ecosystem.
Mm. Yeah, the part you were saying about how you feel there's a tendency to be unnecessarily narrowed down, that's very much something I've seen as well. So as part of the Impact Network for the Brilliant Club, and there were lots of researchers there who had kind of like gotten awards for their outreach stuff. But simultaneously, because they'd been spending so much time on outreach, they'd been getting disciplinary action from their uni for not spending enough time on their specific research area. So that's just quite amusing to hear. You mentioned that your interest in life sciences dated back to your kind of childhood. Could you tell me a little bit about that?
Do you know, it's curious. Why do we become interested in one thing as opposed to another? Sometimes it's because we have a role model, somebody who leads us in developing these interests. Other times it's simply inexplicable. I'm not quite sure why I found it so fascinating, but it was, you know, my parents were not scientists, but I guess there was a general appreciation in the family of nature. So I remember as a child going out, even though I grew up in a city, going out to sort of places of natural beauty, or just in nature and exploring. And I was just a very curious kid. That's actually quite an interesting thing. You know, I think I've heard someone say that we all have that scientist-like curiosity as children. So we continue to ask questions why, and we're not satisfied with being fobbed off with a simple answer. And then some of us lose it when we grow up, and some others continue to ask these questions. So yeah, no clear answer, I'm afraid, to that one.
I quite like that way of putting it. It's kind of like the image of the 3-year-old who keeps asking why until the parent gets annoyed and says, because I said so.
Right, and you would never be satisfied with the answer, right? And so, yeah.
Cool. Yeah, so I suppose you kind of left academia at the stage of early career researcher. I know they're not really early, but postdocs are counted as it because it's such a long career progression. But they often face a lot of rejections when it comes to their work. Do you have any kind of advice for us in building resilience to that?
Yeah, this is a very good question. And, you know, I mean, it's sort of a philosophical answer to this, and perhaps superficially a depressing one. I think that rejection is part and parcel of life. Fortunately, is not the only part of life, because otherwise it would indeed be difficult. And that's, I think, is probably a reflection of my own character and attitude in life in general. I think the best thing one can do with rejection of any kind, be it in a professional, in your professional life, or indeed other personal walks of life, is to focus on what lessons one can draw from this. So, you know, certainly what I have tried to do in my life in the past, and that's what I would recommend to anyone who seeks advice on this, is don't focus overly on the act of rejection, but try to understand where it came from. And so go back and ask for constructive feedback so that you can learn from that experience. You know, if I give you an example from my editorial work, in sort of extreme positive example, sometimes when authors of a manuscript of a paper submitted to an editor appeal that decision, in some cases it may turn out actually that the rejection came about as a result of a misunderstanding. So you can overturn a rejection. In other cases, there can be constructive advice on what to do next, or how to reposition, you know, in the case of this example, a piece of writing, or maybe where to take research further. So I think that there is a positive side to rejection. It can help us grow. So I would focus on this. And of course, the other thing that I would say is never take it personally. You know, if we're talking about a rejection in a professional setting, be it that you have a manuscript rejected, or you're not appointed to a position that you have applied for, never take it personally. It should never have been personal in the first place, and then of course it's not constructive, because it prevents you from growing, learning from this, and moving beyond it.
Yeah, that's one thing I've noticed is kind of complaints about rejections rarely come in the case of the authors directed at editors. They more often seem to come directed at peer reviewers, who are slightly too harsh in their judgment. There's quite a funny Facebook group called Reviewer 2 Must Be Stopped, that I recommend taking a look at.
Yes, that's actually, I've not seen that one. And of course, usually it's the Reviewer 3 that gets the slack, or the flack rather. But so it's interesting because, of course, in the case of many journals, including Nature, the vast majority of rejection, it comes in the first step, and that is the editorial decision. Because, of course, the way that we work at Nature is that the editors themselves will evaluate manuscripts in the field that is the area of expertise and area of focus, and they will make a decision whether that paper is then of sufficient interest, relevance, advance, etc., elegance sometimes, right? There are many different considerations, whether that paper should then be taken for the next step, peer review. So, I would say in my experience, there is plenty of criticism directed at editors for rejection of manuscripts. And as I say, that then in a case like this, or whether it's with peer reviewers or editors, my advice always is try and understand where that decision comes from. Because, of course, in the specific case we're discussing, the individuals who make a decision that leads to rejection have the reasons. They have read the manuscript, they have gone through a reasoning process in order to get to that decision. So that can be constructive. Having an insight into that can be constructive.
And I guess, correct me if I'm wrong here, but if you kind of understand the reasons why an editor might have rejected a manuscript, it puts you in a lot better position to appeal it if you still disagree. Absolutely.
And, so at times, every editor, so right now in the role of editor-in-chief, I no longer handle manuscripts, individual manuscripts, but I certainly spent many years doing so. And I can tell you that every editor has a number of cases sort of at the back of the mind where they entered into a dialogue with the authors, listening to their appeal, why the original decision they made was inappropriate. And I can certainly think of a number of papers which I ended up publishing in Nature. But I'm so glad that the authors appealed my decision, because actually I was, there were some facts that I was not aware of, or maybe I misinterpreted something. So and of course, indeed, as you say, in order to appropriately argue your case, be it a manuscript or in another setting when you've been rejected, it helps if you understand the process, the reasoning process that the other party went through. Absolutely. Because that way, if there are any flaws in that process, you can absolutely point them out.
So now kind of going a little earlier in the publication process, you and your predecessors at Nature have really quite embraced preprints, which I'm overall very much in favor of as well. But not a lot of media houses right now are kind of quoting results directly from preprints. We're seeing this particularly with the pandemic. Do you have any thoughts on this? And do you think there should be any kind of checks and balances, or?
Yes, so it's a very, very good question, and of course, so timely with the pandemic. So the pandemic is actually a wonderful case study of many different elements in the whole science process. So how science is done, how it's communicated, how it's shared, and preprints are one element in that whole chain, if you like. So very clearly, the pandemic illustrates why preprints are important, right? The very rapid dissemination of these sort of complete stories where you've done some research, you've analyzed it, you have a conclusion, and you've written it up as a manuscript effectively, and before or simultaneously while it's going through peer review, you're already sharing it with the community. Now, of course, preprints are open to anyone to access, and so journalists have been writing about them. I don't think this is a bad thing, because after all, knowledge should really be property of everyone, not just the scientific community, which is why we've gone, part of the reason why we've gone down the route of preprints. But of course, what's absolutely crucial is that when preprints are used to communicate discoveries to the general public, it is made really clear that these results are preliminary insofar that they haven't been vetted by other experts in the field. We have seen other examples of extremely rapid communication of science during the pandemic. Think about the announcements of the results of clinical trials of COVID-19 vaccines. Those results were communicated by a press release and a press conference, not even a preprint, right? So if you look at it from that perspective, a preprint is far superior because, of course, there you have written in a format of if you like, a classic paper, the methodology, the results, you have time to scrutinize it. In a press release, this is an incredibly brief sort of distillation of the final conclusions. And indeed, if you follow specifically the dissemination of information about clinical trials, to begin with, researchers and clinicians themselves have been frustrated because they say, well, you know, you, the developer of the vaccine, make these statements, but we can't verify them in any independent way. Now, subsequently, they are, of course, published, and many of them have now been published as peer-reviewed papers. But I'm saying this to illustrate that there's almost a continuum, or at least a wide variety of ways in which research can be disseminated rapidly and very clearly at a time of pandemic. It's crucial that it's disseminated rapidly. But each time when journalists, or anybody else for that matter, talks about it, they have to make it clear what are the levels of confidence that we have in this result. How much has it been scrutinized and approved by the community?
Yeah, so it's kind of like blog post, preprint, published paper, and replicated published paper.
Right, exactly. Yeah, I think it's interesting that you started with a blog, because I guess, you know, these days we see actually elements of new scientific discovery being shared on social media, right? So you have even these smaller snippet-like, you know, almost some dissemination of results by Twitter, but of course, the media is so concise that you can only do so much.
Yeah. I mean, preprints do actually have some level, or a lot of them have some level of kind of vetting. So, you know, like I've uploaded preprint papers, but, you know, if you wanted to upload something that was obviously pseudoscience, they'd probably just reject it outright.
Exactly. And you know, as you say, so that's a very good point that you mentioned this, because then, you know, I guess that there is this responsibility of the potential degree of harm, if you like. So just within the sort of biomedical sciences, medRxiv has a greater extent of checks than bioRxiv, just as an example. Right. So I think that is an example of the great responsibility that the curators of these servers realize and take on board.
Cool. So I want to go back to something you said about how preprints are, you know, almost always open access, and that you were saying science should be open to everyone. I know Nature seems to have adopted a kind of hybrid open access model. Could you talk a little bit about that and the implementation of Plan S?
Yes. So indeed, as of literally a week ago, we are able to offer an open access option on Nature. This is, as I say, a very new development, and to my mind, actually a very exciting one, because the sort of true open access, or gold open access, so in other words, open access which is immediately open and published under Creative Commons license, is really the form that ultimately dovetails and will support the next step, which to me is the real goal, and that is the goal of open science. So, just to qualify this very briefly, if we truly talk about the results of science being, if you like, the property of everyone and being open to everyone, and part of the reason why this is important is because if the whole community can build then on the research that's been done already, then it's insufficient that it's just to be flippant, that the words are open, if you like, but actually the data, the code, the materials, the protocols, all of that needs to be in the same sort of open domain. Of course, another obvious corollary of this is that the more open science is, the more likely that it's going to be reproduced, transparent, and the more likely it is that any mistakes that have happened in the process in the past are uncovered and corrected, right? So obviously, to sort of say a truism, science really does proceed through self-correction, and that's actually a wonderful thing, right? It's a part and parcel of how the process proceeds. So that's to me, that's why it's so exciting that we have at Nature and other journals in the Nature portfolio, that we are now able to offer this immediate open access, as I say, gold open access option. And of course, it's a big switch in terms of how we publish papers and how we open them up to readers. These kinds of changes cannot happen 180 degrees overnight, which is why at the moment it's an option. So you said it's a hybrid, and you mentioned Plan S. So Plan S, a plan created by Coalition S, introduced this term called transformative journals. So the idea essentially is that if you sort of, close one eye and the definition, my kind of working definition of this is that you have a journal which now offers an open access option, but it promotes open access as a concept to the research community and its authors, with the goal that at some point it will become completely 100% open access, as opposed to, what in the publishing circles has been referred to as a hybrid journal, which is a journal that just offers open access, but otherwise doesn't sort of lobby or campaign in any way. So it can stay a hybrid journal forever. So that's a sort of arguably an academic distinction, but that's the sort of distinction that we talk about. So I think this is a truly exciting direction for us to be moving into. And time will tell. We all know, I think, I don't know how many of you are listening from different disciplines, but we all know that open access has so far been adopted and championed to different degrees in different disciplines. So I think we will also see how that plays out in Nature, which of course is a multidisciplinary journal. So we offer a platform for research from many different disciplines.
Lovely. So could you give an example of that in terms of the kind of difference between different fields?
So let me give you I can give you an example from, let's say, let me give you an example from within life sciences. And I'm thinking back to some of the, roles in the past that I've had. So the community in which I sort of grew up scientifically, if you like, so the genetics and genomics community, has championed open science, not just open access, but open science right from the very beginning. So, 20 years ago now, the first draft of the human genome was published. And when the human genome was being sequenced, the data were being made available literally as they were sort of rolling off the sequences, if you like. At that time, it was completely unprecedented. And in fact, the community, as it grappled with this balance between opening up the data straight away and at the same time sort of protecting, if you like, data generators so they could publish and analyze the fruits of their own work without being scooped, the community has come up with a certain set of rules which effectively created that sort of embargo on publishing. So the data were available, but it was the data generators who had this priority of publishing and analyzing the data. So there were some interesting developments, but I'm sort of getting slightly into the weeds just because it's a field that I'm so familiar with, and actually I think it gives us all a wonderful example of how wrinkles in the system can be ironed out quite easily. So, so the genomics community, the evolutionary biologists, and also actually outside of life sciences now, I'm thinking also geoscientists have always been much more open to open science and open access publishing. And so they've been sort of spearheading this this movement in many ways. Some other disciplines have been maybe a bit slower or less vocal about it. And so, for example, you know, within life sciences, molecular biologists were, let's just say, not at the picket line of this particular movement. You know, another discipline which is very clearly embracing the movement is chemistry. And just to qualify, I can't think of any discipline that disagrees with the notion of open access. What I'm talking about is the speed of adoption and you know, how high on your priority list that might be.
Mm-hmm. Lovely. One thing I have noticed is kind of more in the humanities, it's less of a, there's a lot less open access. I know that doesn't necessarily apply to nature, but it's quite interesting. I guess that would apply more to other publishing houses like Elsevier.
It is interesting, you're right. And so I have to say, but by virtue of the fact that nature itself doesn't publish in humanities, we do publish in social sciences increasingly, but not really in kind of what I would define as kind of hardcore humanities, let's say, I don't know, history or linguistics, for example. Springer Nature, the publisher who publishes Nature, certainly has publications in those disciplines also. But although my knowledge of those fields is much more limited, I do appreciate that, of course, often the nature of the data is very different. And the dynamic of the research is quite different. So indeed, you know, often you publish in monographs rather than papers as they are known in the sort of natural sciences. But there are discussions about how you could, as I'm sure you and quite possibly many of you who are listening know probably better than I do, of how the humanities can open up, because there is so much evidence to suggest that open science promotes and enhances research and you know, that speeds up that building on what has been done before. So you know, how you could catalog and open up research that, I don't know, is done even in for example, history research, right?
So going on a bit of a tandem now, in an earlier interview, you differentiated between open access and public access. So Nature, you know, has come under criticism for, you know, charging quite a lot to publish research in an open access format. Now, obviously, there's a kind of commercial trade-off there, but first, can you explain the difference between the two, and do you know how can that kind of be overcome?
Sure. So the basic distinction between open access and public access is that public access just means free to read. And that's something actually that we have been doing for quite some time. So the Springer Nature, the publisher I work for, developed this online functionality called Shared It. So for example, when we share, certainly when I share material that we've published on Twitter, for example, I always use links to Shared It version of our papers so that anybody, you know, my proverbial granddad on the bus, right? Can open and read the whole piece that I am sharing on Twitter. So that's public access, so just free to read. But that material is still protected by a license, so it can't just be taken and reproduced in that way. Now, open access in publishing terms, and for us certainly now that we're able to publish open access, means that it's published under a Creative Commons license. And it's the most permissive license that we use, which means that if you wanted to, you could take whatever we publish and sell it under your own. I mean, you would have to attribute it to the authors, of course, and us as original publishers, but you could even make money out of it. So, but you could certainly take sections of a quote. Now, clearly, plagiarism is not acceptable in any format, but as long as you attribute it, you don't have to ask for anyone's permission. You just have to attribute it. So it's that freedom to take a piece and work with it that really is the crucial distinction when we talk about publishing between public access, so free to read, and open access, so free to modify, reuse, etc. Now you can see how in the context of research and especially natural sciences, when you're dealing with data, when you then extend it to data, how important that is, that you can indeed, with appropriate attribution, often through collaboration, take that information, the data, and then build on that in your own research. Now, it is true that when we made the announcement, probably about a couple of months ago now, that from January we will be offering open access of Nature, we were criticized for how much we said the article processing charge, which is a fee associated with publishing open access, is going to be. It is not a small figure, right, by any stretch of imagination. But that figure reflects what happens during a paper when it's submitted to Nature, how much work goes into, editorial work goes into evaluation, securing appropriate expert peer review, discussion between editors and reviewers and authors to make a paper better, because actually that is the objective of reviewing a paper. The objective is not to just publish or just reject, is actually to make it better. And of course, all of this has a cost. Previously, that cost was covered in different ways. Of course, it was mainly covered by the readers. Now, so to enable that open and free readership, the cost needs to be allocated in a different way. What I would say, however, is when I think about the costs associated with publishing, I think of them as very much costs that are part and parcel of doing research. So ultimately, I think the costs need to be borne as part of the cost of paying for research, as opposed to individual researchers. If you're doing research in the lab, which is the kind of research that I did when I was working in the lab, I never considered that I would need to pay from a PCR machine from my own pocket, right? And yet, doing the research and publishing it so that others can build on it, to me, are elements along the same process. So I think collectively, as a sort of research community with all these different stakeholders, researchers, funders, publishers, employers in terms of universities and so on, I think we have to think about appropriately financing all the steps in research, because research needs to be disseminated. There's no good doing the research and just sort of putting it in your drawer or just posting it on your own website. Earlier we were talking about the importance of distinction between research that's being disseminated through a preprint as opposed to a paper, right? So all of these things have their place, but I say all of them have their place, right?
Yeah, I think one interesting distinction as well in terms of the price is when with really selective journals like Nature, you get into a really odd situation where, because your acceptance rate is comparatively low, you know, for example, like PLOS ONE or JYI, we cruise at about 40 to 50%, and that's reflected in you know, Nature reports, for example. But you know, if you're reviewing 100 manuscripts and only publishing one, because you only charge the article processing cost once it's accepted, you kind of have to, the cost ends up getting concentrated, I guess.
Indeed, that's the case. And by the way, so our acceptance rate is around 8%. And you know, there are journals, actually I think probably clinical journals would be the ones that actually have even lower acceptance rates. But yes, you make absolutely valid point. It's an important point.
Yeah. I think have we had a question come through on the, no? Oh well. Yeah, so sorry, I've just lost my questions. Give me a moment.
That's all right.
So you've been working in academic publishing for what, like 20 years now?
Yeah, very close to it.
So I guess first of all, what's your favorite memory been thus far?
Oh, favorite memory. There are so many. I mean, you know, one first thing to say, I think it's a terrific path and a way of contributing to research community. Actually, I think, you know, I consider myself as a sort of supporter and enabler of research and research communication. So I think all of my memories are very positive, but actually there is one which is a little left field, and it was a very particular set of circumstances. So this was when I was still a manuscript editor, when I handled manuscripts in genetics and genomics at Nature, and I was the editor for a collection of papers from a consortium called ENCODE. And so this was essentially a functional genomics study, trying to understand the elements, the parts of the genome that actually do something actively and define to what extent they regulate the readout of the genome, if you like. And I'm sort of describing it obviously in very general terms. And it was a tremendous effort. It was a huge consortium, many different labs, done on a great scale, including setting standards for subsequent methodology. And, you know, this idea of finally getting to kind of, you know, the cliche is decoding the genome, but it really kind of was. It was setting the foundation, the tools, how cells read out the genomes that they contain. And so when we published this, we decided to, together with the authors, we decided to hold a press conference and a bit of a kind of a fun event to not just engage the journalists, but also engage others from the general public in a kind of didactic way. And so we held an event in the Science Museum here in London. And you know, this kind of biology of the genome and what happens in the nucleus with the genome, it gets quite complicated very quickly to those who really don't understand the very basic principles of it. And so we tried to think how we could explain that these, you know, reams and reams of DNA in every nucleus is actually wrapped up around nucleosomes and sort of packaged. And then in order to read the relevant bits, these things come off of this packaging and become looser. And it's a very dynamic system. And so we actually had some acrobatic dancers who, at some point in the part of this piece, so there was a piece of choreography essentially mimicking what happens in the nucleus when genes are expressed. And so there I was standing in the Science Museum, you know, feeling very kind of elated because this amazing bit of science was published and we were talking about it and so on. And we were engaging with the public. And there were these acrobats, these acrobatic dancers who would come down from the ceiling, they would kind of unravel themselves from these sort of reams of fabric to try and emulate this sort of DNA coming off of nucleosomes. And well, the reason why I chose that is, I guess, because if you had asked me at the beginning of my career, you know, would a paper that you were an editor for inspire an acrobatic performance, I would have just said, well, get away, right? So it was kind of a, you know, a slightly flippant, but a very fun memory.
Cool. There's if for those interested in kind of the communication of science through art and exhibits, there's a really cool exhibit at the Wellcome Trust Museum, the Wellcome Collection, and it's literally the human genome as a series of really heavy textbooks, which I don't know, I really like that. Kind of sit there and get a bit of perspective. So we've had one question from an attendee. So what advice would you have for an undergraduate, or more broadly anyone who wants to pursue a career in kind of scientific editing or publishing?
Mm-hmm. Yes. So so what I would say, so to be a scientific editor, you need to have a PhD, because you need to know what it's like to do research, to understand the process, then to be able to evaluate the demands that reviewers put on authors. You know, I think you, Alexis, mentioned earlier that often the reviewers are harsher than the editors, and it certainly is true. You know, in all the time that I handled papers as an editor, if I had listened verbatim to the recommendations of the reviewers, I think I would have accepted half of the papers that I did. And so as an editor, you have to be able to essentially, it's almost like being a mediator. So, okay, to what extent these additional requests are nice to have, or are they necessary in order to support the conclusions, and how long will they take to carry out? And so for that reason also, editors who are sort of professional editors, if you like, who are in that position, can really only evaluate manuscripts in the areas that they have some experience in. So to put it very bluntly, if somebody gave me a manuscript in particle physics to evaluate, I will be useless, absolutely useless. And not only just, you know, it could be not too difficult for me, I mean, not too difficult. Given some time, I could certainly evaluate to what extent the manuscript was reporting novelty or not. But then, if I was presented with comments from the reviewers asking for additional experiments or analyses, I have no way of calibrating if this work that's being requested is going to take 3 days, 3 months, or 30 years.
Yeah.
And so for that reason, you need to have research experience. So you need to have PhD. So if you're an undergraduate at this stage and you're interested in doing this kind of work, editorial work, then I would say go to do a PhD, taste what it's like to do research. Who knows, you may wish to continue doing research after all, right? So I think that's worthwhile. Now on the publishing side, which is more, if you like, the business side of the business, there the opportunities are broader. So in order to be a publisher, you don't need, strictly speaking, a scientific background or a PhD. So you could consider, after your undergraduate studies, looking into publishing houses, seeing opportunities. You know, one good opportunity actually in general, whether it's regardless at which stage you are in your research career, but if you're interested in switching, is looking for parental leave cover. So often people who go, for family-friendly leave, then an employer is looking for someone to come in for 6 months, maybe 9 months, maybe 12 months. And that's a nice taster for you to get a sense of how this job really is, how that environment as a working environment is. And if you decide that this is not for you, then you've just taken 6, 9, or 12 months out of your other career, and you can always come back. So that's a bit of a taster, a recommendation for you, how you can do that.
Cool. The kind of following on from the parental leave angle, you're the first female editor-in-chief of Nature in the 150 years Nature has been around, and a big inspiration to lots of JYI. So what further challenges lie for women and underrepresented groups in science, and how could we attenuate or even solve them?
Yeah, good question. I mean, so the first thing to say is that, never in my life have I anticipated that my 2 X chromosomes would feature so prominently in descriptions of me. But there we are, and that itself is of course a reflection of a reality in which we live. I think the challenges that remain, I mean, of course, if we sort of go back in generations and we compare the opportunities that women, or indeed other underrepresented groups, have had, the progress has been amazing, right? The opportunities are there. But the biggest, I think that the biggest stumbling block still are the societal expectations, and to what extent we play into them, all of us, because of course we are part of the society. We make it up, right? We make up the society. So it's incumbent on us to question our own behavior and say, why are we surprised to see this person in this role? Or why are we surprised that this person is interested in this as opposed to that, right? And I think all of us, regardless of where we are along this sort of path or journey, to use a cliche, at some point, each one of us is going to catch ourselves thinking, oh, why did I just think that? Why did I think this? And, in some kind of utopian sense, I sometimes joke and say, nobody would ever say, oh, you are the first ginger-haired person in this role, right? So why are these characteristics that should have nothing to do with the in this case, profession that we're talking about, are so important? But of course, in the context of the dearth of previous examples, they are important. They are important examples. And while of course, when some stage down the line when I retire, I would like to be remembered as editor-in-chief of Nature for what I did, as opposed to just for the fact that I was the first woman, it's still important that there is a woman in this role. So I think, to go back to your question, I think what we should all do is question these expectations and assumptions that the society has of, who is suitable for what role, and then also looking at ourselves and our own ambitions and desires. Think about what it is that truly makes us fulfilled and makes us happy. It doesn't matter what others expect of us, and it goes in every possible direction. How we define success in our lives, regardless of who we are or where we are along the sort of progression in our lives. So I think I would say at this point, it's those expectations. And, I just one final thought on that is, so I said the opportunities are there. I should qualify and say that the opportunities are not equal for everyone, of course. And so then for us as members of society who contribute to creating these opportunities, we should be aware of it. So, let's support one another, regardless of who this other is.
Yeah. I suppose in a sense it must be quite frustrating to, you know, like have worked in the field for ages, and then you know, in your descriptions be you know, be referred to as a woman, which I suppose you
Yeah.
might have needed to think about it in that light previously.
No, exactly. And, you know, it is an interesting thing to consider because, I mean, you know, I am a woman. I self-identify as a woman. But then,
not necessarily in a professional sense,
right,
right?
exactly. In a professional sense, it's sort of not the most relevant aspect of who I am and what I am. And what kind of interests me in this when I think back, so, you know, sometimes people ask me these questions, you know, do you, like, was there a role model that inspired you to become who you are, and so on. And I sometimes wonder when these questions are asked, the interviewer is expecting that I'm going to come up with some example of a female role model. And I think the most crucial thing that happened in my life in the past is actually the fact that when I was growing up, I am not aware of my parents bringing me up as a girl. They brought me up as me. And I happen to be a girl.
Yeah.
Right. And I think maybe that is, you know, also what I was reflected in what I was saying before, that we should be supportive and enabling of the person in front of us, focusing on their qualities and characteristics that are relevant in the context. There will be other attributes that this person has, which are by the by in that context, but maybe relevant in other contexts, right? So, yeah.
Yeah, I suppose it would be a little like me being described as the first long-haired CEO of JYI in its 20-year history.
Congratulations.
Yeah, thank you. I would like to thank all my role models who helped me get yeah, so feel free, by the way, everyone, to pop any questions in the chat, and if I've missed any, please shout at me. So yeah, last of all, I suppose you've discussed a little bit about how you know, you very much the way you work now, you know, as editor-in-chief of Nature and previously in your publishing career, has been quite different to how you work in a lab, or in primary research, I should say. So could you speak to a little bit about how you know, a lot of researchers experience loneliness working on their projects, and how that compares with your experience?
Yes, it's a good question, because, you know, we absolutely talk about this sort of danger of loneliness on a project, and I think indeed more so in the early stages of a career than later on. And yet, regardless of which stage of the research career you're on, science is never a lonely enterprise. It's always, you're always part of a bigger picture, a bigger group. And I think collectively, we're all a little bit to blame, I think, for almost fetishizing an individual as a representation of, you know, a discovery or an effort. But, you know, with very, very few distinctions, very few exceptions rather, it's always a team effort. It's always a group. There's always, you know, you're building on something that others have done. You may be collaborating. You're doing some work with others, and others are feed into your project.
I guess, right?
Say again, sorry?
More so now than ever, right?
Exactly, absolutely. And, you know, and in many fields, we deal with analysis of more and more data. It's unlikely that you would have single-handedly created these data, et cetera, et cetera. And then, of course, many different types of analyses. So, I mean, this is something actually that I quite like to emphasize in Nature, when, you know, in the magazine part of Nature, when our reporters write about Nature, or when we, about science, sorry, about research, when we invite individuals to write for us opinions, I like to emphasize this sort of collective team aspect of science, because actually that's how it's done. And so in practical terms, what I would say, you know, to anyone who does feel sort of lonely in the pursuit, in their work, is do reach out to others, because they are right there. And the more we break down this perception that somehow we're all working, you know, this lone genius sort of perception of a scientist, the more we break down that perception, the more successful we will be collectively, I think.
Yeah, and I think that's reflected in, I think that is changing, at least within science.
Yeah.
You know, there's very much now the attitude that having a paper with 10 authors isn't something to be ashamed of, which I personally think is a really positive development. Absolutely.
And, you know, 10 authors in many fields is really very, very few, right?
Yeah.
Yeah.
Especially with respect to genomics.
Exactly.
Okay, so we are running out of time. We're on the last minute. So I would like to thank you very much for joining us. And for anyone who's interested in gaining editorial position experience, we do have lots of positions available at JYI. So journalist, editors, and even editor-in-chief. Thank you once again, Dr. Skipper, for joining us. It's been a real pleasure to talk to you. And yeah, I hope to catch everyone in later sessions today.
Thank you very much for the invitation. It was great talking to you. Thanks.
Yeah, lovely. Thank you very much.
Bye-bye.
All right. Take care. Bye-bye.